Hello everyone, this is me Simran Anand, and today I'm here to explain a problem, a LeetCode problem, which is missing number. So let me just read the question. It says, given an array nums containing n distinct numbers in the range 0, comma n, return the only number in the range that is missing from the array. So first, when we take this question, the most important thing we have to understand the question. So here, what we are given is an array of integers, which is called nums, and it contains n distinct numbers in the range 0, comma n. So you're given some numbers which definitely will start from 0 and up to that particular number n. So suppose if you have three numbers, it would be from 0 to 3. But there is one number in the given input range which is missing from the array, and the question says to find the missing number in the array. So there are different approaches you can come to solve this problem. Let me just spark some light on what exactly the question is expecting from you and how exactly should you come up with the thought process. So here we are given 0, 1 and 3 in the example, as you can see in the screen. The output is 2. As you can see that 2 is the missing number. So how do you decide? This is a small input, so you can see by observation that 2 is the missing number. But what is the logic behind this? You can do one way. First and foremost, easiest approach I could say, the first thing which comes to anyone's mind is first to sort the array. So when you sort this nums array, it becomes 0, 1, comma 3, 0, comma 1, comma 3. And out of that, you can find the missing number by first storing all the, or you can find the, after you sort the array, you know that you can assign indices to each numbers present in that array. For example, 0 has the index 0, 1 will have 1, 3 will have 3. So which one is missing? 2 is the index which is missing in the array. So you're basically going to iterate over the array from 0 to 3 and then check if the index which is the index which is 2, left out index, is present in the array or not. So if the index is not matching or is not present in the given array, then you can conclude that that particular number corresponding to the same index, the number and the assigned index will be same. I hope you understood what I meant. So this meant Z, if you saw the array, you can, and now when I say to assign indices to the numbers, you can use a hash map for that because hash map stores key value pairs. So when you assign indices to the values, 0 will be assigned to 0, 1 to 1, 2 to 2, 3 to 3. But in our case, there is no 2 at all. So you can see that the missing index is 2. The index is there too, but then there is a missing value assigned to it. There is no value for the key you want. So with this, you can conclude using hash map that the missing number is 2. So for this approach, when I said sorting, how you going to sort the array using arrays.sort, the simplest method. Arrays.sort of nums. When you use this, the time complexity is order of n log n. And then this is the first approach. The second approach is, since you have to find the missing number in the particular array and you know that there is only one missing number, what you could do is just sum up all the elements. So when you sum 3 plus 0 plus 1, it is 4. Now, when you do this 4, basically when you find out the total sum of all the numbers present in the array minus the sum of the numbers from 0 to n. So when I said 0 to n, it is 0 to 3. Now you have to include 2 as well. So when I said 0 plus 1 plus 2 plus 3, it is going to be how much? 1 plus 3, 4, 4 plus 2, 6. So you're going to subtract from 6, you're going to subtract this sum of the numbers you have in the question, which is 4. So 6 minus 4 is giving you 2. And you can conclude that 2 is the output, which is a missing number from the array. So basically, this is the method of cumulative sum. And when I said, you have to first sum up all the numbers and then subtract the cumulative sum of the numbers present in this array, this takes order of n. Because you're not using sorting in this technique. There is no sort. There's purely mathematics using here. The sum of all the numbers from 0 to n. You know the sum of n numbers, which starts from 1 to n, is given by the formula n into n plus 1 by 2. Similarly, in this case, you're going to apply that logic and you're going to get order of n time complexity, which is quite optimal compared to the sorting approach we were trying. Before, I was trying to use the sorting approach, which actually took order of n log n because arrays.sort, the time complexity is of n log n. Now, when you do this, the third approach you can come up with. So when I said hash map is one approach, sorting is one approach. Third approach you can come up with to find the missing number. Whenever I say to find the missing number, it asks you to find particular element from a given sorted space or be it a sorted or non-sorted space, the first thing you should come up with a search technique. You can use a linear search, but a more optimal approach is obviously to use a binary search. I'm sure you would have heard of what is the meaning of binary search. Basically, in binary search, it optimizes. When I said it is a better approach than linear search, it optimizes the time complexity, and that is because when you have this array, first of all, you're going to sort this, because binary search technique always works on this sorted data structure. So this array is not sorted. The first step you're going to do is to sort this array. That you're going to do by using arrays.sort. That takes n log n. Now, binary search will take, then followed by binary search. Binary search algorithm will take order of log n. So when you multiply together and sum up the time complexities, it's going to be order of n log n. So these are few of the approaches. So to just sum up, normal summing up the approach, that is one approach, using hash map technique, using the linear search technique, which is the brute force method I was talking about. Like initially, without using hash map for key value pairs, you could just directly compare if the number present at that particular index matches with the value or not. That is a linear scan. You're going to iterate from the array from the starting to the end, and that is going to take order of n square. If you do two for loops, it's an iterative approach, and definitely is a brute force, so it's going to take order of n square. And the final approach, when I explained, was the binary search, and the main optimization technique which was used in the binary search here was to first sort it and then eliminate the unfavorable portion of the array, because you get to know what exactly is the search space you have to consider for your process. That's going to take order of n log n. So let's just see the solution without wasting time. I'll just explain few solutions which I've coded here. The first approach which I was talking about is to sort the array. So when I said first, this is the you're going to get the length of this nums array and store it in the value n, then sort the array. After sorting the array, you're going to then iterate from 0 to n and then check if the value, which is the value, is nothing but okay, the first edge case over here is if I equal to n, return I. This is the edge case which is going to be, you have to consider, so that if you, when you reach the end of the array, that is where you have to stop and you have to just return the element which is missing. So if the index, which is I over here is the index, and n is the length of the array. So when you are moving and the index reaches to the end of the array, that is where you have traversed all the elements of the array. That is when you're going to return I, which is the number, the missing number. Now, the next important condition in this whole logic is if nums at I, that is the element present at the ith index, is equal to the ith index or not. You're going to check it. And if it is not equal, that is where you're going to find the missing value. And the missing value is return I. And if you find that there is no missing number, you're going to just come out of the loop and return -1. So this entire thing will take order of n log n. Arrays to sort is basically n log n. So this was one approach. And let's get to the second approach. The second approach, say, is the binary search approach. And over here, you're going to, as I said, first binary search will work on a sorted space. So when it works in a sorted space, what you're going to do is arrays.sort of nums. As we had seen in the previous example also, we did arrays.sort of nums. First, so get the sorted array. Then, instead of manually, taking a for loop and checking and comparing if the element present at the particular index is equal to the index or not, what you can do is use binary search. Binary search is where you're going to use a lower and an upper bound. Lower bound starting with 0 and upper bound initialized to n-1, n being the total length of the nums array. So when you move from the search or iterate over the elements from the lower bound to the upper bound, that is where your search space lies. So your search space, which you have to consider is between lower and the upper bound. And binary search, this is the main code you can see. While L is less than or equal to h, int mid equal to L plus h by 2. I'm just going to say this, that instead of using int mid is equal to L plus h by 2, that is to find the mid index, you could do another way, that is nothing but L plus h minus L by 2. That also works. That is lower counter plus the rightmost counter minus the leftmost counter divided by 2. That is the one case. And the simpler way is int mid equal to L plus h by 2. That is where you're going to get the middle position of the array elements. Then you're going to compare the number present in the middle position if it is greater than the middle index or not. And if it is greater, of course, you have to eliminate the left portion of your array, because you got a number which is greater than the middle position. So you know that you don't have to use the basically you know that when it is greater than the middle position and the search space is the middle index, then you have to eliminate the rightmost. So that is why you're going to do h is equal to mid minus 1, because you have a number which is greater than your search key. This mid is your target element, and the target element is something which lies in the left side because it is lesser than this particular number you have nums at mid. So you're going to initialize, or you're going to assign h to mid minus 1, basically decrement the h value. So now if this does not satisfy, and if you find that if the number present at the middle index is less than the mid, that is where you have to know that it is the rightmost space that you have to consider, and then eliminate the leftmost space. So then you're going to increment your left value. You're going to search in the rightmost space, so increment left. When you have to consider in the rightmost space, you have to decrement right. Now followed by return L. So return L will return the lower index. Why lower index? Because you're going to return binary search, you're going to return the first occurrence or the first index of the missing number. There may be two missing numbers also, but in the question it said only one missing number, and obviously the first missing number has to be returned from the array. Then only number in the range that is missing from the array. So of course you have to return L, which is the index of the first missing number in the array. This is one of the approach, and this is one binary search approach I've explained. Then I've explained you the normal linear scan approach, you could say, and the final approach is the sum approach, wherein you have to find the cumulative sum and then subtract it, the sum of all the elements from the range 0 to n of the elements minus the cumulative sum of all the elements present in the numbers array given to you with one number missing, and then subtract it from the sum. That is when basically it's nothing but sum of all the elements from 0 to n minus the sum of the elements in the target will give you the return the missing number in the array. So it's a simple code you can see here. Rather, this is the most optimal one and takes order of n. This is based on pure mathematics, you could see. And this is int sum equal to 0, n equal to nums dot length. You're going to initialize some variable which will calculate the cumulative sum of all the elements present in your present in your given array in the question. And you're going to iterate over all the elements present in that nums array given to you, and find the sum of all the elements. Now, once you find out the sum of all the elements, what you're going to do is subtract it from the sum of all the elements from 0 to n range. N is given in the question to you. So you're going to find the sum of all the elements from 0 to n, with 0 to n, including the missing number in it. And that minus the cumulative sum without the missing number is going to give us the missing number. So that is one technique you could use here. You must be thinking it takes order of n square, but it's not order of n square because this is the return statement. It is not inside the for loop, and it does not have two for loops. So since it has only one for loop in it, it will take order of n time complexity. And the space complexity is order of 1 here because we're not using any extra search space. There's only one array of numbers which we are given. So this is something which I would, these three were the approaches, and there's a follow-up question here you could see. Could you implement a solution using only order of one extra space and order of runtime complexity? Yes, you could. And as you can see, related topics are hash table, which I'd explained to you using key value pairs, mathematics, which only took order of one space, and order of n runtime complexity. That is the most optimal. Binary search, order of n log n. Bit manipulation is another technique you could also use here using XOR technique. Sorting, which takes order of n log n. So I hope I have made the solution clear, and feel free to drop any comments you have in the comment section. Stay tuned for more videos, and thank you for watching.